Hi everybody! Today we're going to be discussing trig identities. In the previous two videos we talked about the trigonometrical functions such as the sine, cosine, tangent, the cosecant, the secant, and the cotangent, and we also talked about the Pythagorean theorem. And now we're going to be using those functions and we'll be talking about a more general type of overview of different functions and different identities in trigonometry. But before we start, let's just go back to where we stopped in the previous video. And this was when we have a right triangle with side lengths 12, 13, and x, and we want to find x. And as we remember from the Pythagorean theorem, which states that a squared plus b squared is equal to c squared, so here we can denote that this can be a, this can be b, and this can be c, because c has to be the longest side in the triangle. So we have our a, b, and c values. Now let's just plug them back into our formula. So we just have x for a, so we have x squared. And then for b, we have 12, so we have 12 squared. And this all equals 13 squared, which is 13 squared. Okay, so now we're going to have to do a little bit of arithmetic. So we get x squared plus 144 is equal to 169. And if we were to subtract 144 from 169, we get x squared is equal to 25, which means that if we were to take the square root of 25, we get the positive and negative 5. We get plus or minus 5. But as we can see here, it has to have a positive length. So that means that this negative one is an extraneous solution. It doesn't work. So we know that x is equal to 5. So we found our value. And if we were to plug in 5 for x, then we would have a valid right triangle. So now let's go back to the main topic of this video, which is trig identities. So before we continue with trig identities, I just wanted to show something else which is really important, and this is the conversion of degrees and radians, which will be very important. So I have a circle here. And the purpose of this circle is to be a unit circle, which means that the radius of the circle is simply 1. So this has this angle right here is 90 degrees. And if we have 4 of these 90-degree sectors, this means that one whole circle has 360 degrees, which we probably know from our theories, and from a circle which has 360 degrees in its circumference. So the circumference of a circle with radius 1, say 1 unit, or on a graph, right? So we would have to take the circumference of a circle, which is 2 pi r. And r in this case is just 1, so we have circumference is equal to 2 pi. And this 2 pi is divided evenly amongst these 4 equal sectors of 90 degrees. So this would be pi over 2, pi over 2, pi over 2, and so on, right? So we state that these are radians. 2 pi radians is equal to 360 degrees. This is just a different form of measurement for our circle lengths. So if we have 90 degrees, we have it's equal to pi over 2 radians. And so on. If you just want to convert it, you just have to say that if you have, say, the radians 3 pi over 2, if you want to convert this into degrees, then you would have to multiply this by 180 degrees over pi, because pi radian is equal to 180 degrees. And here these pi's would cancel out, and this would cancel out. We would have equal to 90 times 3, which is equal to 270 degrees. So this is how you would convert from radians to degrees, and it's just the opposite. If you have 270 degrees and you want to convert it into radians, you just multiply it by pi over 180 degrees. and you would get 3 pi over 2 radians. So that's the conversion of degrees to radians. So now let's go on to trig identities. I'll just draw another circle here, which we'll use a little later. Okay, so we know that there are the identities that tangent theta is equal to sine over cosine. And this comes from just saying that tangent is equal to opposite over hypotenuse over adjacent, and this is equal to opposite over hypotenuse divided by adjacent over hypotenuse, which is equal to O over H times H over A, which is just cancels out to be O over A. So, and then if you were to just take the reciprocal of tangent, that's cotangent theta, which is cosine theta over sine theta. Now we go to the reciprocal identities that sine is 1 over cosecant and vice versa. And then we have cosine is 1 over secant, vice versa. And then we have tangent is equal to 1 over cotangent, and vice versa. So these are the reciprocal identities. Okay, so now we're going to get on to some more cool identities, at least, from the other ones. And these are known as the Pythagorean identities. Okay, so the Pythagorean identities. So here we have a right triangle. I'm going to draw a right triangle again. Okay, so we have our just angle right here, theta. And let's say that this is 1. The hypotenuse of this is just 1. Let's say it's part of the unit circle, and this would just be the radius. So then this means that if this is part of the circle's circumference, that means that this is the height of the y of the y value of that point on the circumference of the circle, and this would be the x. So we're going to keep this in mind for any unit circle circumference point. So for point x, y, well, we can just say that the x squared plus y squared has to equal 1. But theta is just, so if we were to take sine theta, it's just equal to y over 1, which is just y. So that means that the y value is just sine of theta. And the x is just cosine of theta, because cosine of theta is just equal to the adjacent over the hypotenuse, which is just x. So that must mean that sine squared theta plus cosine squared theta, this is just another way of representing sine theta squared, is equal to 1. So this is our first Pythagorean identity. And for any point on the unit circle circumference, it's just sine theta cosine theta for the angle which intersects that from the origin of that circle. So this theta. Okay, so using this first Pythagorean identity, we can get two different ones as well. So for the second one, we just have to divide by sine squared theta. So if we divide it by sine squared theta, we get so we have to remember our reciprocal identities, and that cosine over sine is equal to cotangent. So this is just 1. And then we have cosine over sine is equal to cotangent, but this is squared, so we have cotangent squared theta is equal to 1 over sine squared theta is just equal to the reciprocal of sine, which is cosecant squared. So we have our second identity, which is 1 plus cotangent squared theta is equal to cosecant squared theta. And if we were to just divide it by cosine, we would get sine squared over cosine squared plus cosine squared over cosine squared is equal to 1 over cosine squared theta. And this would just cancel out to get tangent squared theta over plus 1 is equal to secant squared theta. So these are the three main Pythagorean identities which will be used a lot in calculus for derivations, for limits, for integrals, and many other purposes. So there are also another few different identities which we'll be covering in the next videos. So if you want to know more about these different identities, you can check out my next videos. So I hope you guys enjoyed this video and learned a few different identities in trigonometry, and thank you for watching.